I'm Editor-in-Chief Forrest Shull, and I'm here speaking today with Paul Zakopoulos on the subject of big data and specifically big data trustability. So hi, welcome Paul. Thanks for joining me today.
Thank you. Pleasure to be here.
We're going to be introducing this issue on software analytics, and I know there's a lot of technical articles coming up on big data systems that people have been building and doing analysis on. But one of the cross-cutting themes I really wanted to talk about was trustability and how you get insight into the data. So I think maybe, Paul, to begin with, you could perhaps introduce yourself and some of the work that you do at IBM.
Yeah, great. I've been at IBM for 20 years. I spent probably the first decade of my career in the research lab, and now I'm kind of on the road with clients. I lead our technical professionals for the information management brand and put a maniacal focus on, evangelizing and understanding our big data platform. I've written a number of books on big data and try to make a social presence around it, so that's what I do.
Great. So speaking from my own point of view, I think of myself as a data analyst, and I do a lot of analysis, but on much smaller data sets than we're talking about in big data. One of the things I like about doing that work is you can go in, you can get an intuition. There's a lot of you can get your hands dirty with the data. And I feel as you get into big data that you lose that ability. We're talking about so many data records. So am I right to be worried about this type of losing the intuition, or are there ways that big data analysts can go about and have a better understanding of what the data really tell them?
Yeah, I think it's a great point when you start to look at, the volumes and the variety of the data you're going to pull into these models, they're going to change. I think the first bit, if I say volume, you're going to get more data. Absolutely. I don't think that you lose your intuition. I think it's a mixture of the two, right? And the analogy I'd use is when I'm driving in my car on a GPS system. If you ever blindly follow a GPS system, sometimes you're going to get lost. Yet it can figure out traffic patterns and alternate routes around construction zones in real time, which has got a bigger aperture of information to make a best route decision than I could ever make. And I don't think you should ever blindly go with the left or the right. I think intuition works, and I think big data technologies allow us to pound out precision and recall statistical metrics on the data that maybe reinforce our intuition or move us in a different way. But the thing I love about a proper big data platform and intuition, as you say, is if IT's doing it right, they're provisioning the big data platform to be one of discovery. And one of discovery should allow you to take intuition, hypothesis test it, validate it statistically, or maybe automate it across literally hundreds of variables using machine learning and kind of mix the two. So I would never want a data scientist to be without intuition.
Great. So, when you talk about being able to go in and test hypotheses, I think that's a great analogy, really, for the process that goes on. I wondered if you could talk a little bit about your experiences there and how to do that. Is it really going back into the statistics and running yet more data mining algorithms? Is it visualization that works at that scale? Could you talk a little bit about what you've seen work well there?
Yeah, I think it's actually a combination of all of them, to be honest. From the glass perspective, right? You're going to need to use visualization techniques in the big data world. And in fact, I've actually seen the emergence of webcasts being advertised to me about how to visualize big data. For example, from a sentiment or a feature extraction from text, the emergence of TagCloud as a de facto standard for big data visualization on words, where I might be trolling through customer service records and want to understand the lexicon of kind of a negative sentiment around a certain product across blogs and websites and Facebook sites and stuff like that, and then present those as larger letters in color-coded red, right? So I think visualization is really key. I think the ability to run literally almost an unlimited amount of variant analysis is another key thing here, right, to get it going. So yes, I'm going to run these models, but it's the ability to go and, let's say, go from 5 or 6, 7 discrete variables in our regression analysis to hundreds of them, and then to be able to run those nonstop, right? And I'll give you one example. The Obama election, right, or his presidential win, if you will, in the United States, and I'm from Canada, so I don't have any sway on Democratic or Republican. I have no opinion, just to say, but those guys engineered their win using big data science. And in some states and voting districts in the state, they would run their election simulations 66,000 times a night. That's what I'm talking about when you step back and say, let's change this variable, let's change that variable. So we'll have to visualize these things, and we'll have to have massive power to run the models over and over again. I think those are two key things.
Great. I guess I was going to go back to an earlier point that you made in talking about, if I'm doing this right, well, I think if I can extrapolate a little bit, if I'm doing it right, there's going to be certain things in the results that match my intuition, and I'll say, aha, I knew it. And then there's going to be the things that really surprise me. What would you recommend for folks to do? I mean, when you get that surprise, I think it could be a surprise that, wow, there's an insight here that I never saw before, or it's a surprise that says, underneath it all, maybe the data didn't really mean what I thought it meant, or it hasn't been recorded very accurately. Any thoughts on how I would figure out which of the two it is?
Well, yeah, if I was trying to think of, if I was in an IT shop and we were pulling out kind of data and a business user went to their discovery zone and discovered something, I think this is really what big data is about. I would expect that the business user would approach me in the IT shop, and then we would have to put some formalization around that data to ensure if it's trusted, right? And in the big data world, we call that veracity, right? And I always think that raw data is a bit of an oxymoron because you actually have to understand your data before you use it. I think that's pretty key here. But I guess if I'm understanding your question right, where do you go from there? I think I found something. When you think you found something, I'm assuming that's the business user who has the context of around what they're doing. Now, maybe this is in healthcare, or maybe this is in a manufacturing process, but let's say it's in a retail example. I think I found an insight that is a trigger of market campaign successfulness. Now I want to bring that to the IT shop, and I want to get some formal process around this so I can start putting assurances on the veracity of the lineage of data. We have to now understand where the data come from, what are the different aspects of the data, how did we get to this data, and then I create a real, put the enterprise hardening around the project. And I think that's the key. It's almost like a relay race when you're running and there's a baton in your hand. There's some point where I'm expecting the business user to hand that back to IT to say, yes, I think I found something, help me validate this. And in order to make a big bet validation, I actually need to ensure that all of the aspects that you do, IT, are hardened into this potential discovery, and then we'll go from there.
Great. So when you talk about hardening it, what goes into that? Could you expand on that a little bit?
Yeah, I guess I would call that information lifecycle management, right? So, for example, let's say I'm pulling in some data and I'm massaging that data. I'm using Hadoop, which is a common use case, as an ETL engine. Well, that tells me that I've got some Java developer, right? They're probably no SQL experts in Java. My gut feeling tells me they're under 35 years old, and they're writing in some MapReduce programs to massage the data and put it into an area where I can discover and visualize it. Well, I need to understand what you did with that data, right? Did you round up, round down? What was the binding agent of a catastrophic failure analysis that I'm doing for a grid? Whatever that is, I need to understand what you did. That's but one example. The other, here's a great example. I'm using personally identifiable data. What have you done to this data to mask it, right? And
that's a great
I'll interject here just to tell you one other thing to think about when we're talking about trustworthiness of data is just because the data sits in HDFS under Hadoop versus RDBMS, why do people think they don't have to mask it? So assuming some developer, went and masked it, what were the corporate standards that we used around masking? A perfect example, as I mask a credit card, a lot of these credit cards, the first 4 digits actually represent the tier of the card, my platinum and my gold and stuff like that. Well, if that isn't a consistent mapping into the underlying logic, that I'm going to run in the analysis, if that's just wild and whatever number, actually that's going to create a problem on my results. So that's an example of hardening it for the enterprise.
Okay. So the types of things you're saying, I think, are well. Let me throw something out, and you tell me if it's right or wrong. I was going to say I think these are techniques that we've been dealing with for a while now. I mean, in talking about any kind of data. When we get into big data, it's just more of the same. I guess there's a lot more data to apply all that to, but it's not necessarily new techniques that we have to worry about.
And I think you just hit it right on the head of what I was getting at in that example. And I'm glad you said it. And I don't want to alarm anyone, but I got to tell you, I go into some of the largest companies in the world, and I have to start here, right? So, yeah, it's really an extension of the issue because you're dealing with data. Now, this data happens to be more in volume. It happens to now include pictures and sound and text bytes as opposed to just rows and columns. And it happens to arrive at our doorstep faster than ever, so we feel we can't keep up. But if you think of the pillars of data governance, what are the things that I talk about with clients? I talk about separation of duties, separation of concerns, privileged users, sensitive data. I talk about data lineage. All of that stuff just remains the same. The data is the data. The data of Paul Zakopoulos used to be, here's my home address, and here are all my purchases, and et cetera, so very row and column. And now they include my wish list and my sentiment around here and the emails that I sent. They've all been connected, but it's still data around me and entities. So you hit it right on the head.
So how, I was thinking that I knew how to apply these techniques until you made that point about the speed at which it's all coming in. I mean, how do I deal with that when I'm looking at bringing in a whole set of emails that comes along with a person, for example? Is it now automated to the point where I could start to anonymize or mask some of that data, or is it really I just need a heck of a lot more people to go in and do the same types of manual things that we've been doing before?
Well, if you try to do the same types of manual things, you're not going to be able to keep up because
that was my thought exactly.
Yeah, and it's interesting here. I'm actually looking right at a article that I have yet to read, but I pulled it out the other day. It's from Narinder Mulani, and she's from Accenture, and the title of the article is Data Velocity: Why Decreasing Your Time to Insight Matters. So when I go and I talk about big data, people are like instantly think I'm going to talk about Hadoop. Right? And Hadoop is but an engine in big data. As a personal plug, I'm writing a Hadoop for Dummies book right now. But anyways, I'll go on. But the problem is Hadoop and data warehouses, these are data at rest engines, right? And so the time when I'm able to do things is after I load into a staging table and I go through this pre-processing work. Then I load it up into my Hadoop engine, and then Hadoop is really, the old mainframe programmatic access batch days, and time to insight's very delayed as opposed to, and also time to cleaning the data. So velocity is key, and part of your big data portfolio has to look at a streaming engine. Okay? And there's a number of them out there. IBM has Infosphere Streams, which I think is the market leader. I'm biased, but the way we've seen it deployed. Twitter Storm is another streaming engine, right? Some folks will try to group in complex event processing here. But as the data comes in, what do you do with that data? And it's the moment the data is coming in where either I'm going to analyze it or maybe I need to anonymize it as it flows into real-time reporting. And that's the key. If you leave it manually, you won't be able to keep up. So you're going to have to look at, high-velocity streaming engines.
And are these things off the shelf that I can pull in at this point, or is it something that has to be done in-house at each IT shop based on the specific data that they're going to be getting?
Yeah, I think the answer is you have to go look at who's providing your big data platform. You can piece it together, piece part. You can rely solely on open source, which I don't think gets you there in the most efficient manner. I mean, you've seen Cloudera and Hortonworks and MapBar, and lots of folks have sprung up around the Apache Hadoop distribution. And that's what they're trying to do is cut the value, the time to value curve of these solutions. So what I say to answer your question is go look at a platform and who is, providing these kind of cultural values that you're going to have to adapt in your organization for big data. If that vendor provides you data anonymization techniques, data archiving techniques, database activity monitoring techniques, who's accessing your Hadoop cluster and when, then you're probably on the right path because those folks have to put those applications now onto this big data sphere.
Great. Okay, great. I guess, and one of the last things I wanted to ask about was, I think in our email correspondence before we had talked about the idea of kind of building up, essentially what you're doing is building up a model behind the data, that you have a sense of what these things mean and how they interact. And the model doesn't have to be perfect and sophisticated from the get-go, but you can iteratively proceed as you go through and have an understanding of the data. Did I just capture the idea correctly there? Yeah,
it's an iterative process. And the goal in IT, and this isn't a new trend. It's to, if you think of rapid application development, This is really rapid model development and to keep agile, right? And I guess the point is, if I had to give an analogy, I'd say I want you to think about like a snowball rolling down a hill, or maybe an avalanche. Or imagine the snowball starts, and the first couple of rotations, they may not seem that impactful, right? But I started inertia. I started energy. And as it rolls down the hill and it goes faster and faster, that snowball that had a circumference of a foot now has a circumference of 20 feet and 40 feet, and every churn makes it faster. And that's what we're doing. We take our models, okay, we build them at rest using machine learning techniques, using Hadoop, using things like SPSS and SAS and R and those kinds of things. Then we score the model. We score the model, then we take the model back and we look at statistical techniques. So two simple ones, if anyone remembers from stats class, is precision, which is a measure of exactness, and recall is a measure of coverage. Now, by no means is that it. That's very rudimentary, but those two stats are pretty decent. If I was pulling out from a blog all of the people who shared their phone number and their name and had interest in buying a car, that would be pretty cool to know what the measure of exactness was and what the measure of coverage was. Coverage being all the potential opportunities, exactness being, hey, I pulled Paul out, but he's not buying a car, he's buying a boat, right? Okay, that's wrong. So once I go and I score that, then I go back to the model. Do I fine-tune the model? Have I found new variants? I put that in the model, and then I test it. Where big data changes things is in two areas. One is the aperture on that model. We used to use, we used to use subsets of our databases, right? We use, 10% of the data. Your SAS miner would come to your 50 terabyte warehouse DBA and say, oh, just give me a terabyte, I'll go build a model. And so we just had these capacity constrained models. In big data, guess what? We get to pad that model with enormous amounts of data size and all kinds of new attributes because I'm going to roll into their, unstructured data as well. And then the ability for me to adjust the model or learn the model is very key as well. So techniques like machine learning provided by Mahout in the Hadoop world, these are the kinds of things that will change the game and allow me to iterate through the model quicker. And to finish quickly, a perfect example of that, in my opinion, is Watson, that supercomputer that won Jeopardy. I don't think I'm giving away any IBM trade secrets, but we weren't going to beat the worst Jeopardy champion until we introduced machine learning. And machine learning gave Watson the opportunity to understand decisions and the aftermath decision of if they were right or wrong in pseudo-real time, as well as to build intelligence of past decisions. And then it would adjust its statistical model and heuristics ranking on did I get the right answer. And that's exactly what will change data mining going forward, is the ability for the computer to run its simulations, to learn from it, and for it to start to choose, new variables and to try stuff. So it's an exciting world we're coming into for sure.
Yes, I know. I was going to say, I love the way you described it. I think this has been absolutely great. Before I let you go, I guess the last question I was going to ask is, we've talked about hypothesis testing. We've talked about the ways that the business persons can really interact with the data and see if their hypotheses are correct. We've talked about building up the models iteratively. Is there anything that you really wanted to make sure people know about that I haven't asked about today?
I would say that when you're looking at a big data project, I would say think about what the big data manifesto should look like of a platform, all right? I don't want you to get pigeonholed to run to Hadoop. I first, in any big data project, is what I would tell you. Start with a business pain point, not a data science project. I've seen 100-node Hadoop clusters that yield zero value, that do nothing, but they're great programming things, and quite frankly, I would love to jump on those. But from a business perspective, do that. And then when you look at a big data project, I think you want to make sure you have all of the pieces. And all of these pieces are going to require this. They're going to require Hadoop engine to store massive amounts of raw data, of short shelf life data, or unproven data that's not yet proven, right? It's going to require an enterprise data warehouse. People think these are going away. They're not going away. We'll use them in tandem like a baseball player might throw with their left hand and catch with their right. If they try to do it with opposite hands, things get clunky. So these two things are the cornerstones of our data intelligence. In fact, GM, General Motors, the company, Randy Mott there, the former CIO of Walmart, has completely just re-engineered their entire data center to land all data in Hadoop. They actually use IBM's distribution, and it works in tandem with a Teradata warehouse in the back. So, that way we store that data is going to matter. And then on top of that, you'll need to look at what we've talked about, the streaming engine. You'll need to want to figure out, is there an engine for me to do text extraction? I think that's a really big thing. Text extraction isn't just sentiment. It could be call center notes, etc. So is there an engine for text extraction? Because that's a lot of work to get done in the open source movement today. And finally, I'd say, is architecture consumable, and is it governable? And probably those 5 things I want people to remember that didn't come up entirely in this conversation.
Great. Well, thank you so much for spending the time with me today.
That was a pleasure. I look forward to talking to you guys again.
Great. Thank you.
Bye-bye.
Bye-bye.